We'll be doing the editorials for LeetCode Weekly Contest 377. The first problem is minimum number game. So basically, in this question, there are two players who are playing a game, Alice and Bob. So they play the game as follows. Firstly, in this game, there is an array A, let's say, and array size is n. Basically, there are n elements in the array. So they'll play as follows. And one more thing, that is the array number of elements, like length of the array is always even. That is mentioned. That is n percentage 2 is perfectly even. So now in each move, the players play as follows. Basically, in let's call a particular move. Let's say in a particular move, both of them will play as follows. That is in the first move. Firstly, Alice will pick the minimum element from the array and removes that. So firstly, she'll pick minimum element from the array, removes it. Then after removing the minimum element, Bob will pick the minimum element from the updated array. Secondly, in the first move, he'll pick the minimum element on the updated array. Once they pick these elements and remove them from the array, there is one more list. There is one more array which is initially empty. After removing minimum element, after Alice removing the minimum element, then Bob removing the minimum element from the updated array. Bob will put the removed element in the list. Let's call this element as x1. Let's call this element as x and this element as y. Then Bob will basically put the element y, append the element into the list which is currently there, and then Alice will append his element into the list. So one move is done and the array size reduced by 2. So both of them will keep playing these moves until A becomes empty. So we should say what is the final array that will be left over if they play in this fashion. So if we look at the constraints, length of nums, basically the length of the given array A, that is in the range 1 to 100, and values in the array are in the range 1 to 100. And one more thing, as discussed, length of the array is even. It's always guaranteed that. So basically, with whatever a array we took, that is named as nums in the question. So nums dot length is even. These are the guaranteed constraints. These are per test case. So let's see how we can solve this. So solving this is very simple. We can just take, let's say we have our initial array. So what we can do is we can sort it. If we sort it, we get 2, 3, 4, 5. So we can observe that in the first move, these two elements will be picked, and first element Alice will pick, next element Bob will pick. Now in the list, what happens is we'll be putting Bob's element first, then we'll be putting Alice element the next. Bob, comma Alice. So that means we'll be putting 3 in the list, then we'll be putting 2. Now on these two elements will perform the next move, where Alice will pick this, Bob will pick this, and in the list will append 5 and 4. So we can just sort the array, and then for every two block, we can put this element first, we can append this element first, then we can append this. After that, for this block, we can append this, then this. And let's say if we have some more elements, in the sorted order, then we can append this first into then this first and then this. Or one more thing we can do is we can just sort and just swap these two positions in the array itself and modify the array itself as the final. So these are the two ways to implement it. Time complexity of this would be big of n log n, and even n square TL is allowed here. Space complexity would be big of 1, assuming it is big of 1, assuming we are assuming we don't consider the space required for the program. So here we have to return a list. So that is a program requirement. Ignoring the program requirement, it is big of 1. So this way we can solve the problem.